to do a quick right now. Hello, hello. Do a quick sound check. Hello. Hello. People hear me? People hear me? Hello? Hello? Hi, everybody. I want to do a quick sound check. Is the mic better right now? Test, test, test. Okay, excellent. So it seems that the audio is working. So let's get moving. So welcome to this weekend Python bootcamp. My name is Gpal. I've been offering these classes for almost a year right now. I'm a self-taught programmer, and since the start of 2018, I've taught over 4,000 students via YouTube mainly. And I absolutely enjoy learning, programming, and teaching. So this is one of the things that I'm passionate about, and I enjoy working with students and helping them learn Python. So what is the game plan for today? So today, the focus is really going to be on the basics of Python. I want you to walk away knowing the basic syntax of Python, things like variables, operators, functions, and so on. And the idea is that you acquire a basic foundation of Python so that you can learn more advanced skills later. And the key thing I want to emphasize here is this is less a lecture and more of it's going to include lots of in-class practice exercises. So don't treat this as a passive class, but rather see this as an opportunity for you to get your hands dirty and to code along as well. So just at the macro level, there are three big principles that guide all these classes that I offer. The first is that we learn best by practice. So I'm going to keep the lecturing to the bare minimum. I'm going to include lots of in-class exercises, and I hope that you take part in these in-class exercises. The second is the 80-20 rule. And the idea is that 80% of the value comes from learning 20% of the concept. So 2 hours isn't a long time. We're not going to be able to cover everything in Python. So we're just going to focus on the most important aspects. There's certain subtle things that we may have to gloss over, but I'll highlight the resources that you need to take a look at if you're interested to know more about these things. And the third idea is that peer-to-peer learning makes learning a lot more fun. I've tried learning things on my own and isn't as fun as learning together with a community. And my hope is that you help each other out and we can learn this together, and it's going to make it a lot more fun and effective as well. So there are going to be two tools that we're going to be using today. The first is Discord server app, which is like a group forum, and the second is Replit. So for those who haven't heard about Discord, it's the place that we're going to ask questions, and it's the place that I'm going to offer all these updates about the classes as well. And if you haven't signed up, so go ahead and sign up because we're going to be using that for the class right now. So go ahead and type in tinyurl.com/let's-learn. This is going to bring you to our unique Discord app, and go ahead and do it. And when you're done, I'm going to show you the important channels that we're going to be using for today. Okay, everyone signed in? Okay, so let me just highlight the important channels for today. The first is class announcements. This is where I'm going to be posting all the relevant post-class materials and notes for the class, post-class exercises and so on. So this is the place that you go and find all these resources. General is just a place where we chat. You can chat with fellow students here. And a very important channel is programming exercises. So this is the place where we are going to be discussing code. If you have any bugs with any issues, this is the place where you can post it and others can help you out. I'm going to be here to help you out as well. Okay, so this is an important place for this class and in the future as well. So that's the first tool that we're going to be using. The second tool we're going to be using is called Replit. So Replit is a browser-based coding tool. The nice thing is that you don't need to download anything to code along. You can share it easily with others. So if you have any issues, you can just share the code, and it's a lot easier for others to debug. It's free as well. So let's go ahead and sign up and write our first line of code. So go to repl.it. Okay. So go to Replit, go ahead and sign up. And if you have signed up, just drop a message so that I know that it's time to proceed. So go ahead and Replit, and let's make sure that everybody is in as well before we move on to the next step. Okay. Anyone having any issues with logging in with Replit right now? Okay, done? Okay, let's get on. So the moment you have logged in to Replit, what you should do is you see this top right-hand corner button, plus new REPL. Go ahead and hit that. Okay. And then search for Python. Right? And select the first option. Don't select Python 2.7, just select Python and create REPL. Okay? I want to make sure everyone on track. Any issues so far? Okay. So let me just do a quick check. Anyone having any issues getting to this stage? Okay, nope. Great. So let's move ahead. So let me show you the main features of Replit, the things that are most relevant for today. Okay. So the first thing is the name of this file, the name of this specific page. So often Replit gives a random name. You can go ahead and change it. You can change it to whatever you want. Let's say in class. Okay. So you can change the name. So this stuff here that you see is called the interpreter, right? So this is the place where the code runs. And this stuff here, this left block, is where we're going to type in code itself. Okay. And if you want to adjust the settings, you go to this button, and then you can adjust the size of the font. Because I want my code to be visible to everybody, I'm going to use a much bigger font, but you don't have to. Okay. And then you can shrink the size of these panels as per your convenience. So let me just show you how you type in any line of code, how you execute it right now. Okay. So let's do the classic programming first line, which is print, right? And then put in a double quote, hello world. I'm going to explain all of this later. I just want to show you the tool first. Okay. And then hit run. And then on the interpreter, you're going to see this text, this string printed out. Okay, great. This is pretty easy, nothing big. But suppose you run into some issue, right? What do you do? So in that case, you see this button, which is like in the center the share button, hit that button, get the link, and go to our Discord server. And in the programming exercises section, you can post it and explain, hey, issue with this code, please help out. So that's what you do if you run into any issues. If you want to show what you have done to others as well, just go ahead and do it. This is the right place to do it. Okay. So that's all when it comes to setup. So if you're ready to get going, I just want to do one final check. Everybody got to this stage? Any issues so far? Anything, any clarification necessary? Otherwise, we can hit right in. Let me just do a quick check on our Discord server app, making sure that everything is okay. Okay, great. I think everybody is okay. So let's proceed. So I want to do a quick kind of a big picture overview of programming to motivate the specific stuff that we're going to learn. So think about programming generally. What is programming at the very high level, at the 30,000 feet view? Programming is all about information processing. You take in data, you do something to the data, and then you output the data. Think about a platform like Reddit. Right? You sign up for an account, they in the database, they create your username and your account, and then based on the number of points you get, they update it. You subscribe to different subreddits, they have information about that, and then based on that, the server outputs a specific front page for you, a specific news feed for you. So programming is all about information processing. But the thing is, information comes in different shapes and sizes, different forms, right? You have strings, you have text, which is, and you have integers, you have different types of information. So the first part of any programming language is to understand all these different data types. And the most common, not necessarily the most common, but the data type that we're going to learn first is called strings. And a string is just pretty much anything that's between quotation marks. So this is a string, just as this is a string, cats, right? All these are strings. Anything that's in between two double quotation marks, or it could be also single quotation. These are strings. So in colloquial terms, we usually call them text, but in programming, these are called strings. Now, right now, we have all these different strings, but there's no way of accessing these strings. So we need to store these strings somewhere. And how do we do that? We do that by assigning variables to strings. So let me do that, and then let me explain how that works. So suppose you create a variable called name, okay? And then let's assign it to, so what's happening here, right? So we know that this is a string. Now what's going on is that we are creating this thing called a variable. Think of this almost as a storage box. It's a place to hold stuff. So we're creating this variable called name, and then we have this string, and we're assigning it to this variable. I want to just clarify this equal sign here, because in math, this means equality. But in programming, this is assignment. You're taking something and assigning it to this variable. Now, what's the value of assigning it to a specific variable? Well, it becomes a lot easier to access it. So if you want to access it, right, what you can do is you just put print, and then you put the name of the variable. In this case, it's just name. You can also have something else. You can have hobby, and then you can say reading, and you can print it out. So go ahead and just try creating a variable, assigning a string to the variable, and try printing out that variable. But go ahead and do that, and then we'll move on to the next step. I'll explain more about these strings. Right, so go ahead, create a variable of your own, assign it to a string, and run the program. Okay. move on. Okay. So the thing is, as I said, anything that's between the double quotation marks, the single quotation marks is a string. So even this is considered a string. The program isn't smart enough to understand that, this is actually an integer. As long as it's between double quotation marks or single quotation marks, it's a string. How do we find out about that? So there's this inbuilt function called type. And whatever you key within the type, it just outputs the type for you. So for example, we say, look, I want to find out type of, well, what type of stuff this is, right? This string. So what you do is you just put in type, put in the object, and then you have print so that you can view it. And then you see this output, class str, which stands for string. Let's say we key in this as well, right? We want to find out what's the type of object this is. You run it, and you find out that it's also a string. Now, some of you may be wondering, wait a second, how do you know about this specific? This is called an inbuilt function. Where can we find information about all these inbuilt functions? Well, you just have to Google them. You just type in inbuilt functions. You go to documentation. You can see the whole list of inbuilt functions. Now, in this case, we were looking at type. Not everybody remembers all these inbuilt functions. People do Google them, so that's perfectly fine. And I just wanted to show you where you can find all these inbuilt functions, right? So you just go to documentation and you find all these inbuilt functions. Now, getting back on track here with strings. So when it comes to these variables, which kind of store these strings, right? There are a couple of rules when it comes to the names of these variables, right? The first is that you cannot use numbers at the start of these variables. The second is that you can't have spaces, right? So it has to be all contiguous. You can't have spaces in between these variables. And at the same time, there's certain reserved words in Python that you can't use. For example, stuff like add or sum. So these are things that there's certain reserved words and you can't use them when it comes to these variables. So the key thing is make sure that, as long as you start it with a text character, it should be fine. That's the general idea when it comes to the naming of these variables. I want to quickly show you how you can combine strings together. So far, let's cut this all out. So far, we have two different variables and two different strings. How can we combine them together in a meaningful way? There are two ways that you can do that. I want to show you the old way, and then I want to show you the modern way using Python 3.61 syntax. So the usual way that people used to do this was to say print. Let's say we want to write my name is, and you hit plus, add, and then you key in the variable, right? So let's just test out. This is the old way of doing it. Let's run it. When you run it, you find that yes, it does work. But with Python 3.6, and this is a specific version of Python, there's actually a newer way of doing it, which I think is a lot neater. So let me show you how that works. The way that you do that is same thing, print. But what you do is you put in the word f, because Python uses this thing called f strings to combine these strings together. You have the same double quotation marks, and then you type in same stuff, except that you have a curly braces, and then you insert the name of the variable, and then you have another curly braces to close it. Okay? You run it, and you get the same stuff. This is a lot neater. When you have lots of different variables, you don't want to, it's a bit messy when you use the old way of doing it. This is the newer way of doing it on Python 3.6. And I highly recommend that people use this. This just looks way neater when you have a lot more variables. So The next thing I want to show you is, so far we have been hard coding these variables, meaning we have been assigning specific strings to these variables. How can we get input from the users itself? So let me type out the syntax, type out the code, and then let me explain how that works. Right. Suppose we want to know the hobby uh, from the user itself rather than hard coding it, right? So what you do is you create the variable as usual, but then after that, you use this inbuilt function called input, and then you insert the question. What is your hobby? Okay. Then let's print out the hobby just to make sure that we got it right. Okay. Let's run the code. Let's say it's reading, try coding instead. Right? And then you find that it outputs the specific variable. So this is how you collect input from the user. You have the input keyword, that's the name of the inbuilt function, and then you insert the question in between uh, these parentheses, right? Now, I want to show you one last thing before we move on to an in-class exercise. You have kind of seen it already. It's the way that you leave comments. So when it comes to programming, likely it's not just you who's going to be trying to understand what's going on. Your colleagues, your friends are going to try to make sense of the code that you write as well. So commenting is a great way to help people understand, to improve the readability of your code, to help to make sure that people can understand what's going on. And the way that you leave comments is by this hashtag, this pound symbol, and then you type in the comment, right? So this is how you leave comments. I just wanted to quickly show that. Okay, we're going to move on to an in-class exercise. We're going to create MadLib games. I'm going to show you how that works right now. So let me share with you all that link. Okay. Give me one moment. Let me open up the link. Okay. Give me one moment. Okay, great. So let me explain how this game works. So using your knowledge about strings and how to get user input, we're going to create this MATLAB game. And let me just explain how that goes before I let you all do it. So let me show you an example of a MATLAB game, right? So here's an example of a MATLAB game. In a MATLAB game, what happens is you collect input from the user. You ask them for a specific noun, you ask them for a specific adjective, and then you mesh them up together in a creative way to do something funny. So let's just make this random here. And let me just show you, no, let's just do Canada here, maybe. Okay. And let me show you how the MATLAB works. So you collect the input from the user and then you string it together in a funny way. Be kind to your Indian footed dresses for a duck, maybe somebody's hole. Be kind to your dresses in Canada, where the weather is always makeshift. You may think that this isn't the lock. Well, it is. So the idea is that you have this creative poem, you have this creative paragraph, and then you take user input and you just mesh it up together. So I'm going to share this link with y'all, which has specific instruction on the number of specific strings that you want from the user. So let me share that on our programming exercises channel right now. So you can take a look at it. Take about, say the time right now is about 4:56. Take about 10 minutes or so to create your own MATLAB game using the knowledge that we have gained so far, right? And this is also a great time for you to ask any questions that you have. I'm here to help. If you have any issues while working on the exercise, go ahead and post your code so that others can help you out as well. So take about 10 minutes and work on this exercise. We'll reconvene back around 5 or 6 in about 10 minutes. Okay, anyone done with the exercise? Any questions so far about it? Okay, take another 5 minutes or so, and then we can move on. We can wrap up this activity and then learn more about integers and floats. Okay, anyone done with the exercise? Go ahead and share the code on Discord so that we can take a look at it. Okay, we have a couple of responses streaming in. Let's just take another 3 more minutes and then let's wrap this one up and let's move on to the next activity. Okay, so far we have 2 responses. If you have finished it, go ahead and share it. We'll take another 2 more minutes and then we'll move on to the next part. Okay, another 1 more minute and then I'll showcase some of the work that uh, some folks have done and then we'll move on to integers. Okay, okay, go ahead and wrap up your MATLAB game. I'm gonna show a couple of responses that some of the students did, and then we can move to the next part. Okay, let's take a look on programming's channel. Let me pull a few. So let me go ahead and show a couple of responses from students. So this is from Chandler. Let's open it up. Let's take a look. Okay, so we have all the instruction and everything. It's great. Okay, so let's run this program and let me just test this out. Okay, what's your name? Let's put Jake. Friend's name, Amy. Read code. Okay, there was once, let's read this MATLAB game. There once was a person named Jake who loved another named Amy. They went for a read to decide if they wanted to code. Oh, this is neat. This is a nice MATLAB. So some of you may have realized that I had this extra stretch challenge to ask you how to kind of separate these lines of code on. So when you look at this MATLAB, you find that it's all meshed up together. Sometimes you may want to separate uh, them into different lines. The way that you do that, I mean, this was really a stretch activity, was to use backslash and n. So the moment you have backslash and n, what ends up happening is it breaks it up in a different line. So this is something that I didn't teach, but I just wanted to throw it out there in case people were interested. So backslash and n leads to a new line. So let's just try out the same thing again, but with this, and let's see how it goes. Amy, read code. Right now, what you find is that it breaks it up. It breaks up the line. So that's what this \n does. Okay. So I want to show one more response, and then we can keep moving ahead. Okay. So let me just work on one more response. Let's look at this. Okay. So this is another MATLAB game done by someone else. Let's take a look at this. Let's run it. Okay. Let's put your first now. Let's put tree. And now let's put lab, adjective, fast, put tall. Okay. Tree was being fast and then decided to be tall with lab. Right, neat. That you get the point here, right? So the idea is that you collect the input from the user and then you string it together in this F string, F template, which is exactly as we learned. So this is neat, guys. Once again, if you're having any issues getting to this stage, any doubts about strings and so on, go ahead and just ask the question on the programming exercises channel so that either I or someone else can help you out. But so far, so good. Excellent. So let's keep moving. Okay. So far, we have learned about strings. So strings are a data type, but there are other different data types as well. The other very important other data type being integers and floats. So let me explain what these are. So let me list out a couple of integers. So integers are stuff that we are used to, the numbers that are countable. Numbers like 1, 31, -1. So any number without a decimal point, that's pretty much an integer. A float, on the other hand, is something that has a decimal point attached to it. 3.0 is a float. 4.0 is a float. And suppose we want to test this out, the way that we do that is, let's say we put print type, and let's say we want to find out the data type of this, which is an integer, right? So let's cut out all of this stuff first. So this is going to show us that it's an int. But what happens when we add a decimal point to it? It's going to become float, right? So basically, think of whatever numbers you usually count with as integers. Anything without a decimal point is an integer. But when numbers start having a decimal point, think of them as floats. This is just a very simple heuristic. So just as with numbers, you can perform basic arithmetic expressions in Python itself. So I'm going to show you a couple of them, and then I'm going to explain what's going on. So you can do the usual addition. So 1 plus 3 or 4. That's going to output the value. You can subtract numbers. 5 minus 3, right? That's going to show you 2, right? You can multiply numbers. That's also normal. Nothing different. Division gets a little bit more complicated. There are different versions of it. So let me show you. Let's say you want to find out 1 divided by 3. This is the normal division, and it's going to show you all the way to the float here. But you may not have seen this. Let me explain what this is. So when you have this double forward slash symbol, that's to find the quotient. So 3 divided by 2, but in this case, you just want the quotient, right? So that's what this double forward line does. And you see 1. Suppose you put in, say, 5. This is going to show you 2. It's just a quotient. Suppose you want the remainder. The way that you get that is you put print, put the value, and then you use this percent symbol, and it's called modulo in programming, and then you find out the remainder. So 5 divided by 2, the remainder is going to be 1. Okay, so these are pretty much the most basic arithmetic expressions that you can expect to perform. There are way more arithmetic expressions, of course, but these are the basic ones. And I want to show you a more complex arithmetic expression, and I want to show how order of operations work when it comes to programming in Python. So let's say we have something a bit more complicated. Let's say 10 minus 3 uh, multiplied by 3 multiplied by 2. So how do you think this is going to, so what do you think is going to be the output of this? In what order do you think Python is going to make sense of this statement? Any responses? I want to get a few. Okay, so -8 is the response that's coming in from people. Let's run it. It's -8. The reason why it's -8 is the multiplication operation takes precedence, right? And in this case, because the multiplication takes precedence over the subtraction, you're going to see 3 multiplied by 3, which is 9, 9 multiplied by 2, which is 18. So this is actually equivalent to 10 minus 18, which is -8. So there's an order of operations. There's a specific ordering to figure out, what takes precedence and so on. But the basic rules that you learned in school pretty much stay true even when it comes to Python. So anything that's in parentheses takes priority. So I'd highly recommend that you use parentheses when you have multiple operations going on so that you get a sense of what's actually taking precedence. So parentheses, of course, is at the top most. And then after that, you have things like multiplication, division, and followed by addition and subtraction. By the way, I'm going to send you all class notes after this whole weekend bootcamp, so you don't have to worry about taking notes you don't have to worry about taking notes. I'm going to send that out. But the key takeaway for now is that when you have multiple operations, make sure that you use parentheses so that it's a lot clearer both to you and anybody reading your code what's the specific order of operations. The next thing I want to show you before we move on to the next in-class activity is the specific syntax that some of you might have seen, might end up seeing. So suppose we have a specific variable called num1, and we want to add 10 to it, right? One way that you can do that is you can say num1 equal num1 plus 10. What's going on here is Python is adding 10 to this variable, which is 10 to begin with. So in this case, this becomes 20, and then it assigns 20 back to that same variable again. This is perfectly fine. So when you print this out, you're going to see 20. This is perfectly fine. But there's a neater way of writing this, because right now, what's going on is that you are repeating the same variable name. Instead of that, what you can do is, let's code this out. You can write num1 plus equal 10. Run this code, and you're going to get the same response. So this is just the same thing as this, the same deal, right? It's just a more convenient way of writing it. So you can also have num1 times equal before. There are different operators that you can use with this kind of concise expression, but I just wanted to show it because you might end up seeing other people using it. So I wanted to show that. So the next in-class exercise we're going to do is to create a tip calculator. So let me share that link with you all right now. Okay, so let me explain this tip calculator exercise first. So the idea here is that we want to create a tip calculator based on our knowledge of integers and floats and getting user input. So the idea is that first of all, we're going to ask the user for the bill amount and then the desired tip percentage. And we want to print out the final value that the user needs to to pay. So that's the goal of this exercise. But before we proceed, I want to show you something really quick here because this is going to come in handy for this exercise. So whenever you get user input, right? Let's put input num, right? Right. You put input. You say, hey, please enter a number. Whenever you get any input from a user, take note that it's always going to be in a string format. So if you type in print type input number, so let's do this. We're asking for a number from the user. Let's say we enter 10. Oddly, you find that the type of this variable input number is still a string. That's because whatever input is collected from the user, it comes in a string format. And suppose we want to do mathematical processing the same way that we want to do with a tip processor. You want to convert the string variable into an integer or a float. And the way that you do that is by adding this extra inbuilt function on top of that. So let's say in this case, we just want an integer, not a float. We type in int and we wrap it around input. So same thing, let's run it. Then now you find that this object, this variable is an integer. So the key point here is that you can convert the variable data type from strings to integers and floats, and you can also convert it from integers to strings. We're going to see that later, but I wanted to show that because that's going to come in handy when it comes to this exercise. So let me go ahead and share this on programming exercises. Take about 5 minutes. So the time right now is about 5:20. Let's reconvene back at 5:25 and go through this tip calculator exercise. So I've shared it on our Discord server app. And if you have any questions about getting user input, converting it to integers, how you calculate the specific tip and so on, go ahead and ask on programming exercises or the YouTube comment section. I'm going to be taking a look at it right now. Take about another 3 to 4 minutes, and then we will wrap it up. Wrap up this activity and then move on to if-else statements. Okay, if you're done with the tip calculator, go ahead and share it. Okay, take another 2 more minutes, wrap up this activity. Let's come back, let's go through this, and then we'll move on to the next part. Okay, another 1 more minute, and then let's reconvene back. Okay, let's get back. Let me take a look at the stuff that y'all have done. Let me take a look at that. So far, any questions about integers or floats or getting string output? So let me take a look at the stuff done so far. So we have the tip calculator activity. Okay, let's take a look at the work by someone here. Okay, so let's run this and let's try to make sense of it. Okay, so the question is, what's your bill? Let's say put $100. Okay, neat. Okay, so this is interesting. So in this case, the tip percent was hard coded, and then the bill amount, what happens is they get it as a string and then they convert it into a float, which is the right thing to do. And then you have this output, which shows the bill and then the tip. This is perfectly fine. It shows that you know the concept really well. But what you can also do to stretch this further is to collect the tip percent as an input from the user so that it's a bit more customized. So that's something they can do, but this is a perfectly valid answer. So one of the questions that people had was, suppose we have this really gnarly large number with lots of decimal points, right? How can you make sure that you only display 2 decimal points? Right? There are 2 ways of doing it. The first is to use this function called round, ROUND, parentheses, open parentheses, close parentheses. So that's something that you can look into. The second way you can do that also is to use string formatting. So go ahead and Google string formatting 2 decimal points. There's a way to do it. So both those methods are perfectly valid to get that desired 2 decimal point uh, output. Okay. And depending on whether you want to round it up or you just want to cut it off, so you decide which method. But I'm not going to focus on that in the interest of time. We're going to move ahead instead. So take a look at this program itself, right? Suppose the user keyed in a negative value when it comes to the bill. Obviously, that doesn't make sense. It's supposed to be greater than 0. But let's say they keyed in minus 100. And you get this output which says the bill is minus $100 and the tip is minus 15. Now that sounds a bit funny. No restaurant pays you to go there. That would just be odd. So what that shows is, if we just let the program run on its own, it's not going to be robust. There are bugs that it's going to run into. There are going to be issues that it's going to run into. We're not going to get the desired output. So this is where control statements come in handy. They help you kind of decide which code block you want to execute depending on which condition. So let me show you how control statements work. Okay. So let's go back to our in-class exercises Python file. So let me show you how if-else statements work. But before I do that, I want to show you a very relevant data type. It's called Booleans. That's going to be important here. So Booleans are things that are either true or false. That's it. That's what a Boolean is. It's either true or false, and it's called a Boolean. And we're going to need this knowledge when it comes to if-else statements. So let's run this. You're trying to figure out the type of this stuff. It's called a Boolean, and you see that it outputs this bool symbol here. So Booleans have interesting properties when you compound them together. So for example, if you want to figure out what true and true is, it's true, right? But let's say you want to find out true and false, it's going to show you false. So I want to explain. Let me give you an example to motivate it, right? So suppose there's this statement, right, which says Zach is 6 feet tall and David, taking this up, 7 feet tall. So this is a compound statement, right? You have two different statements here. And if both of these statements are true, Jack is 6 feet tall and David is 7 feet tall, which is pretty tall, this compound statement is going to be true. So true and true leads to true. But suppose either one of these conditions is false. Suppose that David isn't in fact 7 feet tall. So Jack is 6 feet tall, but David is 7 feet tall. This whole compound statement is going to be false. So true and false is going to be false. Now, this may seem a bit, this whole activity may seem a bit far-fetched, but I want to show you how the logic works because this is going to come in handy when we use if-else statements. Okay, so that's the AND operator. We also have another operator when it comes to combining these Booleans, and it's called OR. So true or false, what do you think this is? Do you think this is going to output true, or do you think this is going to output false? Okay, so this is going to be true. So let me explain the reasoning here. So imagine Jack, so let's switch the statement. Jack is 6 feet tall or David is 7 feet tall. So in this case, you just need one condition to be true. Suppose that Jack is in fact 6 feet tall, but David isn't 6 feet tall. In this case, the statement is still correct because you just need one condition to be true. So that's the reason why true or false, in that case, that statement evaluates to true. So suppose you have print true, true. So this is also going to be true, right? If both those statements are true, when it comes to OR, it's also going to lead to true. But instead, suppose this is false and false, false or false. So meaning Jack isn't 6 feet tall and David isn't 7 feet tall either. In that case, this whole statement is going to be false. So when it's false or false, it's going to be false. Okay, so this may seem like an arcane exercise, but you're going to see why it's important that we know this. Okay. Now, before I show you if-else statements, there's another concept that we need to learn, and then we're going to be able to get on to if-else statements. So we rarely assign variables to Booleans, right? We're not going to create a variable and then assign it to true or false. That doesn't happen. Instead, what happens is that we often try to compare different variables, and as a result of that, these booleans are going to be created. So let me show you an example. So you can compare numbers, integers, using things like greater than, less than symbols. So in this case, what do you think this is going to evaluate to? 3 greater than 2? Yes, that's true. So you're going to see true. So that's a greater than symbol. You also have a greater than or equal to. So that's another symbol. In this case, that's also going to be true. If you key in 2 here, that's also going to be true as well. Suppose you can also use the symbol. So for this is going to be false. 4 less than 4, that's going to be false. And then there's another operator that I want to show you here, which is a double equal sign, which is actually equality. Is 4 equal to 2? That's going to be false because 4 isn't equal to 2. That's why you see false. And then another operator here is not equal to. Is 4 not equal to 2? Yes, that's true. 4 isn't true. Isn't true. So that's true. So all this is going to come in nicely. It's all these concepts are going to coalesce together when it comes to if-else statements. So let me show you an example if-else statement here, and then let me explain the syntax. So suppose we collect the bill amount. We have this variable. Okay, let's assign it to 100. Suppose the bill amount is greater than 0. We want to say print amount. And in the case that it isn't, let's print out so can't be negative. So let's run this first, and then let me explain what's going on here. So you get the output right amount. So what's going on here? So we're assigning 100 to this variable called bill amount. And then we have this if-else statement here. And what it does is it checks whether the bill amount is greater than 0. And in the case that it's greater than 0, if this is true, this is the statement that gets printed out. But if it isn't true, meaning it's false, and the bill amount is in fact negative, what you find is that you get this message, nope, bill can't be negative. So let's just try out a negative value. It's -6. Now what you find is that you get this output. Now, some of you may wonder what's going on here, right? What's with this indent? So the way to think about indent in Python is it's helping you separate code blocks. So in other programming languages, you use things like a curly braces to separate out code blocks. In Python, we don't use that. Instead of that, what we use is code blocks. So this is all the code that gets code block if statement evaluates to true. So whenever this statement is true, this is the code block that gets executed. And the way that you do that is either by using tabs or spaces. In this case, Replit is smart enough to do the auto indent for us. So the point I want to make here is that whenever you copy the code of somebody else or copy code from the internet, be really careful because you don't know whether they're using tabs or spaces, whether it's all going to be copied properly and so on. So that's something that you want to be aware of. So let's step back and let me explain what's going on with this if-else statement here. What's the basic syntax, the schema when it comes to these if-else statements? Well, basically, you want to put if, and then you want to specify a condition that either evaluates to true or false. You want to write the code block if, in fact, the condition evaluates to true. And in the case that it isn't, else, you want to put this, you want to specify what's the code you want to run if the statement evaluates to false. So that's a basic if-else statement. Now, suppose you have multiple if statements. How can we combine them together, right? Suppose we have final score for an exam, say 97, and we want to assign a grade to the student. We want to figure out what's the grade that the student should get. So let me show you the wrong method first, and then let me show you the right method. So one could say, okay, you know what? I know how if-else statements work. So let me combine a bunch of if-else statements together, and let's try to find out the grade. So you can say if final score greater than 93, you want to create this variable called grade and assign it to A. Okay. Then you can say, okay, let me go and specify the next condition. If the final score is less than 93 and the final score is greater than 90, the grade is minus, and so on. So you can keep on doing this, and then you can put in another if statement. But this is the wrong method. Why? If you were to just combine a bunch of if statements like this, isn't going to be the most efficient thing, because suppose the final score is in fact greater than 93 and the grade is A, you just want to exit that code block. You don't want to process another, you don't want to evaluate it again. So the way that you kind of compress the steps is using what's called an elif statement. So let me show you how that works. This is the correct method, right? Same thing, if final score is greater than 93, I'm going to assign grade A. Okay, here's where the new concept comes in. This is called an elif, which is just short form for else if. So meaning if in fact this first statement evaluates to false, you want the program to evaluate the next statement. And let's say if else if final score less than 90, final score greater than 85, great. So this mistake, greater than 90, you want it to be minus. And then let's say we are a little tired, just in the interest of time, we have a final else statement that just says grade equal E or less. And let me just run this and let me explain what's going on here. Oh, okay, we have to print it out. Okay, print grade. Great. So what's going on here is that same thing. We have this final score variable, it's 97, and then we have this if, elif, else block here. So what the program does is it evaluates, okay, is the final score greater than 93? Yes. If that's the case, we have this variable called grade, and it becomes A. And that's it. It just exits the whole if else statement block here. But suppose that this is in fact 92 instead. What happens is, okay, there's a typo here. Let's run this again. Okay, if it's in fact 92, what happens? The first if statement is evaluated. Is final score greater than 93? Nope, that's false. Okay, in the case it's false, it moves on to the next statement. Okay, is the final score less than 93? Yes, that's true. And is the final score greater than 90? Well, that's true as well. So yes, both these conditions are true. True and true is equal to true, as we have learned from the exercise. So grade is equal to A minus, and that's it. We just exit. So the idea is that when you have these else if statements, you reduce the number of steps. So it makes the program a lot more efficient. It becomes a lot easier to read, and it becomes more computationally efficient. So right now we're going to move on to the next in-class activity. Let me type in the link here. It's called Replit, where we're going to apply this knowledge of if-else statements here. Some numbers. So let me explain this activity. So using your knowledge of if, elif, else statements and how to get user input, we want to create a program. Okay, let this load up. Okay, great. So what we want to do is that we want to get one number from the user. Let's get an integer from the user. And then we want to write an if else statement to figure out whether the number is a positive number, a negative number, or neither. Because if it's zero, it's neither positive nor negative. So that's the simple program that we want to write. Spend about 5 minutes working on this. I'm going to share this on our Replit server. So using our knowledge of if else statements and how to get user input, write a simple program to figure out if the number that the user has inputted is either positive, negative, or neither. And if you have any questions about what we just covered, go ahead and post it on programming exercises or the YouTube comments. I'm going to be taking a look at that right now. Maybe we have a couple of responses streaming in. If you're done, go ahead and share it so that we can take a look and learn from what you've done. So let's take another 3 more minutes and let's wrap up this activity and then we can move on to the next part about while and for loops. Okay, take another 2 more minutes. Any questions about what we just learned? Booleans, comparison operators. If you have any questions, now is a good time to ask. Okay, just 30 more seconds. We have done it. Go ahead and submit it. Send it on the programming exercises channel. We're going to review it. And then we'll move on to while loops and for loops. Okay, so let's move ahead. So let me showcase the work that some of y'all have done. Let's take a look at the first submission here. Okay, so the activity, this in-class exercise required you to get user input and to do some processing to figure out if it's positive, negative, or neither. Okay, so let's run this program. Let's see the whole flow, and then let me explain what's going on here. Let's put in a number. Great, find out it's positive. Let's try out a negative number. Negative, great. 0. Okay, program works. Neat. So let's see what's going on here. First of all, we have this variable called number, and then what's happening is we get input in the string format, and then we convert it from string to integer. And then after that, take a look at this work. This is neat. So what's going on is that we're trying to process to figure out, okay, is this a positive number? Is this a negative number, or neither? So what happens is, first of all, in this case, there's evaluation to figure out, is this number greater than 0? Because if it's greater than 0, the number is positive. And if it is in fact greater than 0, you print this statement and you leave this whole code block, right? You leave this whole code block and you move on to line 9. But in the case that it isn't, you move on to evaluate, okay, is this equal to 0? So this is the equality check, right? You're trying to check, is this number equal to 0? And then you output the appropriate message. But if neither of these conditions is true, then obviously you just move on to the else component and you print out this section of code. So one of the questions that people had was, what's this else if? Think of it as almost another if statement, but it's combined with this whole code block. It's else if. That's what it's a short form for. I hope that helps. If you have any questions, feel free to direct message me after the class as well. I'm going to stick along in the chat section so I can help you address any specific doubts that you have. But else if, that's what an elif is. Okay, so let's move on. So we're going to learn about while loops. So while loops allow us to control the flow of programs. So let me show you an example of a while loop and why we need it, and then we'll move on to the next activity. Let's take this all out. So a while loop comes in handy when you want to execute a specific code, when a specific section of code, when certain conditions are met. So let me show you an example here, and then I'll explain what's going on. So let's say we create this variable called founder of Tesla, and let's assign it to Elon Musk. Okay? I'm just going to type it out first. I'm going to explain it later. Answer incorrect equal true. Okay? While answer incorrect equal true, user response equals input. And in 1 second, I'm going to explain what's going on here. Okay? I'm going to explain this in a brief second. Great. Let's, okay, let me explain this program, but let me just run this program first so that you get a sense of how this works. So the program, it's like a quiz program where we ask, okay, who's the founder of Tesla? Let's say we put in a wrong response. We put Jeff. Please try again. Who's the founder of Tesla? Okay, let's say we hit the right answer. And the program stops. So let me explain what's going on here. So we hard code the answer. And then let's say we have this condition which says answer incorrect equal true, because the answer is going to be incorrect when we start this quiz program. So how does this specific section of code work? How does this while loop work? So whenever you have a while loop, whenever you have the while, you're using the while keyword, you want to specify a condition. And as long as that condition evaluates to true, that specific section of code is going to run. But in the case that this section of code, if the condition is false, the following section of code wouldn't evaluate. So what's the flow of this program? Answer incorrect, we've hard coded that to true. So while answer incorrect is equal to true, yes, in the first instance it is, we collect the user response. So that's where this question comes in. And then we check if, in fact, the user response is the correct one. So if user response is equal to the answer, founder Tesla, we print out, print congrats, and we change this condition, this conditional variable, to false, because initially it was true. And then we change it to false. And then what happens if this is in fact true? This else statement doesn't get evaluated. And then the program tries checking this condition again. Is answer incorrect equal to true? That's false, because right now answer incorrect is in fact equal to false. There's another way of doing it. I'm going to show that to you, but I just want to show you how a while loop works. When it comes to while loops, the key idea that you need to take away here is you need to specify a condition. And then when the condition is met, you want to specify code that should run when that condition is met. So there's another way you can do this. Let me show you how that works. So instead of this whole variable, you can take that out and use breaks in your while loop. So let me show you how that works. Let's take this out. So this is called an infinite loop. Not always recommended, but I want to show you how that works. So while true, so this is going to always evaluate to true because it's true, right? This is always going to evaluate to true, right? But instead of changing the conditional variable here, what we can do is that we can use this keyword called break. And what happens when it comes to a break is to break out of the whole while loop here. So let's try this again. Let's hit the right answer. So what's going on here? We key in the right answer right away. prints congrats. And what happens is when you hit break, it exits this whole section of code. So that's what break is doing. Okay. So any questions about while loop? So the key takeaway is have specify a condition, change the conditional variable so that it does evaluate to false at some point so that you can stop the running of the code. Otherwise, you can use an infinite loop. I wouldn't recommend this, but I wanted to show you how this works as well. So the best way you can learn this is to try this out yourself. So here's an in-class activity we're going to work on right now to consolidate our understanding of while loops. So it's called guessing in class. Let me explain how this activity works, and then we'll spend about 5 minutes working on this. So what we want to create here is a mini game, okay? In this case, we want to get the user to guess a 2-digit number. And I've decided here, I've just hard-coded the winning number as 94. So what we want to do is, using our knowledge of while loops and if-else statements, we want to offer feedback on whether the user's guess is greater than or lower than the winning number, and to stop the program when the user guesses correctly. So that's the goal of this program. So let me go ahead and share this on our programming exercises panel and take about 5 minutes to work on this. Okay, so here's the exercise, about 6 right now. Take about 5 minutes to work on this. After that, we're gonna learn more about for loops. And if you have any questions about while loops, now's a good time to ask on the programming exercises channel or the YouTube's comment section. Okay, any questions about this exercise? Any doubts about while loops? And if you have completed this, go ahead and share this. Okay, we have the first few responses coming in. Okay, take another 2 more minutes to work on this. Okay, another 1 more minute, and then we'll reconvene. If you have any questions, now is a good time to ask, clarify. If this activity is a bit more challenging than the previous ones, so if we do take a little longer, it's okay. It's a little bit more complicated. Okay, folks, let's get back. Let's take a look at this. So for this guessing game, the idea is that we want to get the user to guess a specific number, and we want to give them feedback on whether the number is greater than, less than the winning number. And if it is in fact the winning number, we want the whole program to terminate, and we want the user to be notified about it. So let's run this first, and then let's explain what's going on here. So in this case, the winning number is decided to be 42. That's perfectly fine. And let's run the program. So what's your guess on the winning number? Let's say we guess above 50, 42. Try again. Okay, let's put 10. Okay. So we guess the right number. Excellent. So this program is working fine. So let's explain what's going on here. So the winning number is decided. It's set as 42. And after that, what happens is we have this while loop here. So while condition is true, so meaning this definitely evaluates to true. There's this variable called user response. And then we're getting this string and it converts an integer. An integer is appropriate here because these are things that we can count. We don't want floats coming in. So integer, that's the right way to do it. That's the right data conversion. And if user response is equal to the winning num, we see that we have this correct, the winning number is so and so, and then we break. So meaning if this is right, this is true, you break out of this whole while loop. But in the case that it isn't, you find that there's this comparison, right? Is it less than the winning number, or is it greater than the winning number? And that's why you get this uh, sections of code to give you the feedback. So as I said, this is a bit more complicated than the previous activities that we did. If you have any doubts, feel free to ask me or anyone else in the programming exercises section now or later. So I want to move on. We have about 20 minutes left. I want to cover how functions work. I want to cover how for loops work, first of all, and then I want to quickly move on to functions as well. So far we have learned about how a while loop works. So while loop is great when you have a specific condition that you are evaluating. But in certain cases, what you want to do is that you want to run a specific piece of code a specific number of times. So suppose I want to print out hello world 10 times. The wrong way of doing it, let's start the wrong method first, is to say print hello world, and then to copy and paste it. That's the wrong way of doing it. In programming in Python specifically, we have this concept of for loops, and let me type them out first, and then let me explain how they work. So you say for I in range 10 And hello, let's run this. And when you run this, you find that it does in fact print out hello world 10 times. So let me explain what's going on here with this for loop. So in a for loop, I mean, what's going on here is that we are specifying a range, right? And we're saying, hey, run over this specific piece of code for this many times. And this I is just used to track the specific iteration. So instead of I, we could put anything else here. We can put num, we can put anything else. And you can also print out this specific, the variable. So this is helping us keep track of where we are in the for loop. So we can print num. So let's take a look at this. Okay, now when we do this, you may notice something. Let me just take out this hello world so that we know, so we can keep track of this variable. One of the things you may notice is, wait a second, it starts with 0 and it ends with 9. So what's going on here is that when you just specify one number when it comes to this range, the way that it understands it is it starts with 0. In programming in general, and especially in Python, things start with 0, not with 1. It starts with 0. And the way that Python understands this is it doesn't go all the way to 10. It stops at 9. So this is seen as the maximum that it doesn't reach, right? So if you key in, let's say, 20 here, it's going to go all the way from 0, 19, but it's not going to print out 20. So let's try this here, right? And you do find that's the case. Now, suppose you want a bit more control. So in this case, whatever number you key in, it starts with 0, and then it ends one number before what you specify. But suppose you want a bit more customization. Let's say you want to print out numbers, all the even numbers from 2 all the way till, let's say, 10, right? What you would do is you would specify the variable that you want to start with. So we want to start with 2, and we want to go all the way till 10. But if you want to go all the way till 10, remember, we're not going to reach 10. We're just going to reach 9. So we want to go 11. And then what we want to do is that we just want the even numbers. So that's where we specify what's called a step variable. So we key in T2, and let's print out num here. Take a look at this. So in this case, we just print out all the even numbers. So the key point I want to highlight here is that in this function, I'm going to explain what functions are later. It accepts both either a single argument or 3 arguments. So if it just accepts a single, when you just use a single argument, it just starts from 0 and goes all the way to one number less than what you specify. But when you have 3 arguments instead, this first argument becomes your starting argument, starting parameter. This becomes your ending parameter, and this becomes the step function. So the nice thing about for loops is that you can use them to sum up things as well. So once again, the best way to learn is to apply them in an in-class activity. So let me show you the in-class activity that we're going to do to consolidate our understanding of for loops. It's called sum calculator. So we are a bit short on time, so I'm whizzing past, but if you have any questions, feel free to ask me. So let me explain how this activity works. So the idea is that we want to use for loops to find out the total sum of all integers starting from 1 all the way through 50, inclusive of 50 as well. And if you do have a bit more time, try to find the total sum of all even integers from 2 to 50. So the time right now is about 6:13. Let's take about 5 minutes, and then we'll reconvene, go through this, and then finally we'll go through functions and then wrap up this class. So let me share this on our programming exercises channel. And if you are done with that, go ahead and submit uh, your Replit link on programming exercises. And for those who are a little stuck, here's a clue. You need to initialize a variable before the for loop to calculate the sum. That's the clue. You need to create a variable to keep track of the sum before the for loop. So that's the clue. Okay, spend about another 2 minutes to work on this and wrap it up, and then we can proceed onwards. Okay, take another 1 more minute. Take 1 more minute and wrap it up, and then I'll show you how to approach this question. Okay, folks, let's get back. Let me show you how to approach this right now. Okay. So the first challenge was to figure out, okay, what's the total sum of all integers from 1 to 50 inclusive? Meaning what we wanted to do was we wanted to figure out 1 plus 2 plus 3 plus 4 all the way to 49 plus 50. So that's the challenge, right? That's what we want to figure out. So the first thing we want to do is we want to, so the moment we hear this, we think to ourselves, okay, we definitely need a for loop. That's what we need. But then we want to keep track of the for loop, right? We want to keep track of the sum in the for loop. So what we do is that we initialize this variable called sum, and we set it to 0, okay? And then we want it to sum up all the numbers from 0 through 50. So let's do for I in range. And remember, whatever you specify, whatever number you specify, it's not going to reach the numbers. If you put 50, it's only going to reach till 49. So we want 50. So we actually put in 51 here. Then we say sum plus equal I. Right? So this is the same as saying sum equal I sum. And when everything is done, we want to print out the sum. Okay? Let's run this. So we get 1275, which is the right answer, which is what you should be getting for the first part of this challenge. So let me explain what's going on here. So you're using this variable to track what's happening in the for loop. It goes all the way from 0 to 50. And then inside the for loop, we are adding that specific number. So 0, 1, 2, 3, 4, all the way through 50 to the sum. So that's how we get this summation. So let's move on to the next part of the challenge, which was, okay, find the total sum of all even integers from 2 through 50. So this is where we use the three arguments in range instead of the single one. So you say for I in range, we want to start from 0, go all the way till 50. So we type in 51. And the thing is, we just want the even integers, right? So this is where we say, look, we want to move it by 2 integers all the time. So 0, 2, 4, 6, and so on. So this is where we put in 2. We say, let's put sum plus equal I, and we need to initialize it again. I commented that out earlier. Put sum 0, and then let's print the sum at the end of this for loop. And let's do this. You see 650, which is the right answer here as well. So that's how you approach this specific challenge. Okay. Since we're a little short on time, I'm just going to go ahead and show you how functions work. We may not be able to have time to do an activity per se, but let me just show you how functions work. So just a little bit about functions first. Why do we need them? So the thing is, when you're writing more complicated pieces of software, inevitably you're going to repeat code, and you don't want to do that though. You're going to use the same kind of code over and over again, and you don't want to do that. You want to reuse the code that you have written before. So you want to make the process a lot more efficient. You want to make the code a lot more understandable, and that's where functions come in. So functions essentially help you reuse the code that you have written somewhere else. So let me show you how you define a function. So the way that you define a function is to say def, and then you enter the name of the function. Let's say I say my func is equal. So let me explain what's going on here. So what we're saying is, okay, I'm defining this new function and I'm calling it my underscore func. I'm not taking in any arguments here. I'm going to explain what arguments are later. And what I want the function to do is I want it to print hello world. That's all that I want it to do. So far, what we have done is that we have defined the function, and that's all that we have done. What we want to do is now we want to call that function. We want to invoke the function. And the way that you do that is just type in the name of the function. In this case, my underscore func. That is it. So that's how, at a very high level, a function works. But now, suppose in this case, we didn't accept any specific variables, any arguments into the function. Let's say we want to write a new function that, let's say, takes in 2 strings and creates a sentence, right? So let's say we say call this string combination, okay? String 1. Let me type it out, and then let me explain what's going on. Let me type this out first. Explain what's going on here. Okay. So let me explain what's going on here. So now, unlike this function, which didn't take in any arguments, we are putting in arguments here. Think of arguments as stuff that is like inputs into a function, right? The function does something and creates an output, but you need to take an input for certain functions. You're creating this function where you're asking the user to key in 2 strings. I mean, it doesn't need to be called string 1 here, but that's what I've decided to call it. You could call it anything else. You can call it hat, you can call it username, whatever you choose. And then in this specific function, what's going on is you're just simply printing out a combination of the first string and the second string. The way that you invoke a function like this with defined arguments is you key in the name of the function, and then you key in the specific number of arguments that have been demanded by it. So far we have just been printing stuff using functions. But one of the most useful ways that you can use these functions in programming is if you ask them to return specific values. So instead of printing this out, we can just ask Python to return a specific string or specific value. So let me show you how that can work. Let me type it out first in the interest of time and then explain it really quickly because we're running out of time. Let's say we create this new function called user edition, right? And then we take in two numbers. Now what happens is we create this new variable called total equal num1 num2. Let's return total. So let's just call this. Yeah, this is fine. Okay. And let me use this here. So let me explain what's going on here first. Here we are creating a function called user edition. We're taking in two variables called num1 and num2, and then we're creating this variable called total, which adds up these two numbers, and then we are returning this total. So what is returning doing? Essentially, the output of this function is total. We're not printing out anything. We can't if we choose to, but when we say return, this is the defined output of this function. So what can happen is you can assign this output to specific variables. So for example, you can say user total. So that's the variable, and we want this 3, 3, 4, and then we can print user total. So take this all out from this. So what's going on here? Right now, we are invoking this function. We're calling this function called user edition that has been defined here. It takes in two values, 3 and 4, and it returns the total, which is 7. And then we're assigning 7 to this specific variable called user total. So that's what's going on here. So that's how, at a very high level, functions work. So we don't have much time right now, but here's a challenge for those who want to practice writing functions. So go back to the for loop exercise, the summation exercise, and try to create a function that allows you, create it. Whatever you wrote, try to create a function so that it's a lot easier to calculate the sum of numbers from whatever start and end point that you define. So that's an activity we want to sharpen your knowledge about for loops and sharpening knowledge about functions. So we just have about a minute. So I'm just going to wrap this class up right now because I want to be on time. So what's going to happen after this, right? So I'm going to be sending you all, let me stop. So what's going to happen is I'm going to post optional practice exercises on the class announcements section so that you have additional experience. Because the best way to learn programming is to practice. So I'm going to post slightly more complicated exercises so that you can practice your skills. And I'm going to cover them so I'm going to be available from 8 p.m. to 9 p.m. EST this Wednesday. So if you have any questions about these optional practice exercises, that's the best time to ask on Discord because I'm going to be there for that continuous hour. But in the meantime, if you do have any questions, feel free to ask me on Discord. And I'm also going to post class notes for what we have covered so far after the second weekend bootcamp tomorrow at 12:30 p.m. EST. I want that class to be over, and then I'm going to post the class notes. And next week, I'm going to run a similar bootcamp with a data science focus. So whatever we have learned, we're going to apply that to analyze data, to understand more on packages like NumPy and Pandas, to do some real data analysis using Python. And I'm going to send the details via email. And if you found this class helpful, please consider a Venmo donation at gpal09. Otherwise, you can also go to the link buymeacoffee.com/gpal. That is it. That's the wrap up for this weekend Python bootcamp. Have a great weekend, guys.